Hello, my name is Henri Gört, and I work at Konecranes as the machine data platform lead in our digital center organization, which is responsible for the design, implementation, and delivery of the Konecranes digital services. And I would like to tell you today about the work we are doing to define an OPC UA information model for cranes. I will be taking questions in the end of my presentation, and I am also prepared to answer questions during the presentation. So if you have a question to ask, feel free to interrupt me. So when we talk about an information model, in this case, what we are actually defining is a companion specification. So the full name of the companion specification can be read from the screen. And as you can see, what we are defining today is part one of several parts in the series of crane companion specifications. At Konecranes, we have been using OPC UA internally for close to 10 years now, and we've had some good experiences with using it. And that was one of the reasons why we decided that OPC UA was the way to define the standard information model for the future integrations for cranes. Actually, a partner organization, one of the organizers in this event, you know who you are, actually suggested the creation of a crane node set already several years ago. And while we did not start working on that at that time, we are now in the final stages of finalizing the specification. So the target today is to get a release candidate out early next year and start the OPC Foundation 90-day review process. We are modeling the crane to make it faster, easier, and more efficient to integrate the crane as part of an advanced material flow solution and to enable Industry 4.0 machine-to-machine communication. The machine flow solutions we are building today are comprised of not only cranes with assisting smart features and automated lifting solutions, but an ecosystem of services and machines interacting with each other over standard interfaces to form the entire material flow solution. And we are working towards this goal together with members from the Verband Deutsche Maschinen- und Anlagenbau, the German Mechanical Engineering Industrial Association, and also members from the OPC Foundation and FEM. Also, Machine-Aid project consortium members have recently joined the joint working group as OPC Foundation members. And this joint working group includes members which are crane manufacturers, control system vendors, software service vendors, and research organizations. The chairman of the working group is Eberhard Becker, and I am the co-chair. And about Machine-Aid project, the Machine-Aid consortium members are utilizing the information model for describing data access to and from the digital twin in the project. And they're also using OPC UA in general for access control in the project. So how are we modeling it? The crane information model is built on OPC UA for robotics, OPC 40010-1, OPC UA for machinery, and other specifications. The crane OPC UA server will be compatible with existing services that support the robotics companion specification from day one, meaning the crane information model aware clients. And that is because we are building the crane CS on top of the existing already released part one of the OPC UA robotics companion specification, and we are subtyping the crane from the motion device system type of robotics. Also, we are including support for the machinery companion specification in our model to serve our asset management and identification use cases. So Wolfgang was talking about these companion specifications that don't include the OPC UA for machinery. The robotics is one of them. What we are doing here is we are including the machinery identification type in the crane motion device system type, and then we are also including the component identification types in the motion devices. More on that later. The other use cases we are covering with part 1 of the crane companion specification are the communication of limitations from external systems to the crane, supervision, and condition monitoring. Here you can see a hierarchy of some, but not all of the various types we have defined and included in the companion specification. The ones in green are crane-specific types, which we have defined as new or which we have subtyped. And the ones in blue originate from the robotics model or other companion specifications. So, for example, the state and the operating mode, which Wolfgang mentioned, those are actually ones that we are getting by inheriting from the robotics companion specification. So those we have decided that those types serve our purposes, so we are able to use those and represent the state and operating mode of the crane in the same way. But we are also including crane extensions here. The crane extensions cover things like protective functions and other features of the cranes, and they can be associated with one or more motion devices within the crane. So, for example, an overload protection function will prevent all hoisting movement from all of the hoists on the crane in an overload situation, and you might have more than one hoist. So we are linking the protective function to the specific motion devices. And about the motion devices, so the robotics companion specification was a good basis for modeling the crane. On the left, you can see a figure from about a portal manipulator from an early draft version of the robotics companion specification. And on the right, a figure demonstrates how we have mapped the different crane components using the motion device system type. The motion device system is the entire crane, and the hoist, trolley, and crane bridge are modeled as separate motion devices with one or more axes each. So a motion device might have one axis for linear motion and one axis for rotation if the component has the capability to rotate. The relationships between the different crane components are modeled using non-hierarchical references of OPC UA. So we are modeling the crane with both hierarchical and non-hierarchical references. The simplest crane to model is probably just a single hoist without any cross travel or long travel. This would be a motion device system with only one motion device. Whereas the crane that you can see here, you actually have the hoist mounted on the trolley, which is traveling along the bridge. So there's a distinction between, or we can model more complex cranes and also these more common simple cranes with the model just fine. Like I said, the target state is an advanced material flow, where cranes interact with, for example, paper machines, extruders, controls, robots, and devices in the same environment via OPC UA for cranes and OPC UA for robotics. So the basic motion device interoperability relies on the robotics CS, and for crane domain information such as tonnage, overload protection, speed limitations, and designed working period percentage, OPC UA for cranes expands the information model. Also, the companion specification provides tools for vertical integration with cloud services MES, ERPs, and so on. So that is represented by the different OPC UA clients in the top of the diagram. Thank you. Any questions?